Guys, what is going on? What is going on? We're building a little more smart contract stuff. We're learning more Solidity. This is fun. This is fun. So I think this is part 5 of the Solidity series, I want to say. Side note, I'm gonna take a quick drink of water in a second. I've been messing around with the Sepolia testnet. I've got some fun builds that I think I'm gonna do for you guys that are like putting all this stuff with the Remix ID and deploying contracts to the Sepolia Ethereum testnet. It's gonna be fun. It's gonna be fun. So let's dive in, guys. I'm cleaning up the apartment. You can hear the washers going in the background. Got the dryer going, the dishwasher washing. It's time to dive in. You know, I'm a little bit tired. I've been kind of just catching up on sleep, trying to get the fitness back in line. It's just my body's readjusting in this moment. So I'm terrible, and you guys can see it's February right now. But when it's summers, I'm like thriving. You know, the energy's there, workouts all proper, all that stuff. But anyway, so what we're learning today is interfaces. Let's see. The easiest way to enable, well, today's overall concept is going to be Calldata. So let's talk about that, right? We've covered it, Calldata. Now we're in interfaces. Okay, so the easiest way to enable one contract to interact with another is to defining the target contract. Interesting. So interfaces serve this purpose. For example, interface iToken function get balance from this user address external. Okay, so that's kind of cool. We can use this interface to properly communicate with a token contract that implements the get balance method. Interesting, right? So interfaces are to interface with other contracts is what I understand. Seems why they named it interfaces potentially, right? We can use this interface to properly communicate with a token contract that implements the get balance method. Token address we want to communicate with. The user balance is the address we want to look up for the balance for. So he's defining a variable called balance and setting it to the interface token address, and triggering a function called get balance and passing in the user address. Okay, so that seems convoluted. Let me move my face, but I don't think it's too bad. Guys, I love how the background, by the way, of my face just like matches the vibes of all. It's just, that's God for you. You know, he just lines things up, and he's just him. You know, he's great. Okay, so behind the scenes, Solidity is creating a message call that encodes the call data for this get balance call. Your goal, alert hero, use the iHero interface and the hero address passed into the send alert to alert the hero from the sidekick contract. Okay, so I imagine we're going to have to define an alert. So we'll say string alert, and maybe we could say something like iHero. We'll have to pass in, interesting, the token address. Now, how are we going to do this? Let me move my face some more, kind of look at this. Okay, so maybe we don't have to do that. We just have to trigger the alert, right? Like this. And do I need to pass anything into the alert? I don't think so. But the iHero, do we need to pass in something, the token address or something like that? I feel like we're going to have to, right? All right, just pass to send alert. Okay, so maybe we pass in the hero, right? All right, let's try to run it. String alert. Okay, not going to work. Oh, sweet, guys, we did it. Okay, so we interfaced successfully with the other contract. So we just called this function from this interface, passing in the hero from this sidekick, I suppose. So that's great. We want to move slow and really understand these things, guys. Because the other day when I was deploying to the Sepolia test network, I'm so happy I moved as slow as I did through this whole deal, because I was like really just on top of it. It was all making sense and coming together really well. So if you're not understanding something, slow down. It's not a big deal. We're not in a rush to get anything done. I know everything's trying to rush you, but take a beat. Understand this stuff and how it's interacting and interfacing with each other as best you can. Because when you move slow and you move like a pro, you figure it out. You know, you build the stuff, you do the thing, and everyone's like, "Wow, that's fantastic! You really did it." And that's the most important. You actually move the needle when you do that in your life. So if you don't understand something in this whole series, go back, because we're going to compound on top of all this stuff. We're going to build to the next deal, and we're going to do some Web3 stuff with Web3.js, where we're going to interface with some front ends we're going to build. So just get it all as strong as you can is what I'd say. Okay, so function signature. The first step to forming call data manually is taking back the cache 256 hash to the function signature you are targeting. So, for example, if we're trying to call Rumble, so function Rumble external, we need to take the cache hash of Rumble and grab the first 4 bytes. As it turns out, those 4 bytes are this hexadecimal right here. This would be our entire call data to make the function call to Rumble on a contract. Okay, I don't understand that. So as it turns out, those 4 bytes are this. I don't understand that part at all. I don't understand it. I understand that that's the hexadecimal. Why are we pulling up 4 bytes though? Is that just relevant to the cache 256? Okay, so your goal, alert hero manually. Alert the hero manually this time. Fill in the function signature for the hero's alert function. Notice that we are taking the first 4 bytes of the hash of this function and passing it in as call data to the hero. Okay, so one more time. We're taking the first 4 bytes and passing it as the call data to the hero. So here's the first 4 bytes. We're doing it the signature. And it's, oh, I see right here. And we're passing in that signature to the ABI encoded pack for the hero. Okay, so what do we need to do? Fill in the function signature and the thing right here. So got it. Is this what we need to do? No. Okay. Turns out those first 4 bytes are this. How do we know the first 4 bytes are this? That's where I'm just, not understanding. So we need to take the cache of the Rumble. Oh, I see. So we need to take the cache 256 of this. So how do we get that? How do we get the cache of 256 right here? That's what we need. Let's say how to get cache 256 hash. Boom. Here we go. Okay, so we just pass it in like this, but we just need the first 4 bytes. Alrighty. This is a little bit convoluted in my brain. So we need the bytes here of the hero, right? Is that what we fundamentally are asking for? Oh no, it's doing that. Sweet, there we go. Okay, so bytes, we have hero. No? Guys, I'm not sure. So let's take a look-see. Oh, we just needed to pass in the alert. Why? How does that make sense? Okay, let's read it one more time. So we need to take the cache this, meaning we need the alert function. Okay, not a problem. That will, and then of course it needs to be in quotes. Alrighty, got that one. I think we got that one. Here we go. Okay, so encode with signature. Let's go. As a bit of a shortcut to the previous stage, we can use the method ABI.encode with signature. This method will do everything we did in the last stage in one function. Okay, so bytes, memory, payload, ABI encoded packed, bytes, cache, Rumble. And it will replace this with this. So what are we changing here? We still have the bytes memory, basically bytes for memory versus bytes memory. So the payload of that, but we don't have to define it here. We just encode with signature like this. And that'll, I guess, automatically compile these 2 things for us. It'll already define the type for it and then also the cache number. Awesome. So, let's say to do alert with the proper call data. Interesting, folks. All right, so, and if you want to add the arguments, you can add them with the signature and use a comma separated with the encode with signature method. If Rumble took 2 uint arguments, we could pass them in like this. Okay, so we have 2 uint arguments like this. Boom. 256, you define it, and then pass in the arguments. That would be the payload. So that seems like what we're going to have to do here is something like that, and then pass in that payload. Okay, that would be why they're teaching it to us. So alert the hero by calling the alert and passing in the number of enemies and whether or not they are armed. Be careful, the uint is an alias for uint 256, but only 256, and it will work with the ABI.encode signature. Okay, we can learn more about the details here, or not. So hold on, let's do this real quick. Bytes memory payload, and this is going to be our ABI.encode with signature. And what we want to do is actually this bit right here is what it looks like. So we need to fill in the enemies, the Boolean, I suppose. So the hero is being called here, and we need to, what do we need to do? Alert the hero by calling the alert and passing the number of enemies, whether or not they are armed. So we need a uint 256 for the first one here, and then we need a bool. And it's super important that none of these things have spaces in it, right? So typically we do this, like have a space there. Don't do that with this one, is I suppose the message here. Okay, so that and then we take that payload, pass it in right here, and I think that's all we need to do. Fingers crossed. Fingers crossed. Let's go. Let's go. Oh, I was about to celebrate so hard. I was about to celebrate so hard. Okay, so let's think about it. What's going on? We have a revert here. Test alert 1, test alert 2. So we have bytes memory payload. I'm going to try bytes 4 memory payload. No. Okay, so it is bytes memory payload. I'll replace uint256 with just uint to see. So let's think about it. So the payload it's reverting the call here, and the payload is supposed to be the encoded signature of this call data. Or this is the call data, the payload. Okay. I'm not sure, guys. I'm not sure, to be honest. So let's take a look-see. So we have function send alert. Looks like we were supposed to put all that inside of that instead of making the payload. So very close, very close. This will make sense in a second. We weren't supposed to assign it here. I saw that gap, so let me just retry. But we're supposed to take this bit and just pop it in where the payload is. And no semicolon at the end there. No? Okay, that wasn't it. I thought that was what we were supposed to be doing. Okay, let's look at it one more time. So we have alert, we had rumble. We had a rumble this whole time. Okay, so maybe that's what it was. Let's undo. Let's try the payload real quick, and let's try the alert. Because I was like, that should have worked. Why would that have not have worked? But okay, it still didn't work. All right. Well, let's try just passing that directly in then, like this. See what we can make happen. All right, what's going on? So we have ABI encode with signature, hero.call, ABI encode with signature. I see the same, right? Alert, uint 256 bool. Got it. That's what it was. Nice. This is going to be so fun when we get to deploying stuff on the Sepolia testnet or one of the testnets, Ropsten test network, one of them. It's going to be good. It's going to be a good time. So let's go back real quick. I just want to read the details for a second. So behind the scenes, the ABI encode with signature is doing a few things for us. It's helpful to take a look behind the curtain every once in a while to understand why it does and behave the way it does. It's a good idea. So let's take a look at the example, contract example. But we have the send data. We have the ABI, similar thing. We're passing that ABI encode with signature. It's taking the first 4 bytes of the cache for us. So how does it work? It's taking the cache hash of the function signature of received data uint256. Okay, so right here, boom, it's taking those first 4 bytes and appending the value 5 padded to the 256 bits. Interesting. This result, why does it do that though? Why does it append 5 padded out of the 256 bits? Why would it do that? Signature issues. Okay, they have a tool to just check that that's the right cache for the call data here. Still just, I don't understand why they append the 5. Is that just as a test? Okay, so anyway, you'll notice that this makes the function signature part of the call data very brittle. One small change to the signature in your code will be a completely different call data, which makes sense, right? You're like hashing and scrambling everything. So that makes sense. The smart contracts on the other end will not understand the value you're trying to call in that case. Okay, that's super interesting. Let's say, for example, you forget to take out the argument name and you type with ABI code with signature like this. The resulting from keeping the hash of X is going to be completely different. So this is kind of what we talked about, the binaries thing. Like within the binaries, representing a negative number, it's just, let's say here's negative integers and then here's positive integers. So they just represent the very first number with a negative number. But that's not what you're doing when you're hashing with hexadecimals. It would be like representing a positive number is like OX01, right? It would be like positive numbers. And you might think, oh, for negative numbers, maybe it's just 10. But it's like, no, it's saying it's like completely different for a negative number. Now, that's just a parallel example, but so it's not just hashing the data and just add the X. For instance, if we're encoding with the call signature, it's doing a whole other deal. Okay, so only include the function name. Don't include any visibilities or keywords or spaces. Right here, delimit without spaces. So you could do this, but it's massively different hashes. So good to know. All right, let's move on. So arbitrary alert, taking call data. If we take call data as an argument to a function, we could pass that arbitrary call data along to another contract. Guys, let's kind of define call data real quick. What is call data in Solidity? Let's do this. So call data is used to store function arguments that are passed into from an external caller. So I suppose is Calldata, it's not like the MSG sender stuff, or is that technically Calldata? Is this the Calldata technically? Calldata is used, okay, let's see. The owner address variable is defined as Calldata because it's a function argument passed in from an external caller. Oh, okay, so it's just like our parameters, our arguments. Is that what Calldata is? Okay. Just try to get like a really granular grasp of our understanding. Again, we build those tiny bricks, we're going to build a beautiful brick house. So that's the goal here. So taking Calldata. If we take Calldata as an argument to a function, we can pass that arbitrary Calldata along to another contract. This can be super useful, especially in contracts that require many people to pass their approval before a transaction is executed. So it's like before you can check out, you got to have multiple checks. Government, like they have to have multiple people sign off on a bill or something. So let's reread that one more time. This can be super powerful. If we take Calldata as an argument of the function, we can pass an arbitrary Calldata, or we can pass that arbitrary Calldata along to another contract. This can be super powerful, especially in contracts that require many people to pass their approval before a transaction is executed. We'll talk more about governance, proposals, and multi-signature wallets later on in the course, and you'll see that storing Calldata for later use is critical for maximum flexibility in these cases. We should definitely build some multi-signature wallets. I think that would be really freaking cool. That would be one cool thing. I've got like a generic Twitter thing on the Zapolia testnet that I think is really cool. But I think a multi-sig wallet would be really interesting as well. So we'll get to those things. We'll build up to them. But okay, so your goal, pass the Calldata. The sidekick needs to be able to relay any Calldata along to the hero. Update the relay function to take data and send it to the hero Calldata. Okay, so update the relay call function to take data. Well, it looks like it does take the data. Send all the data as Calldata to the hero. Interesting. I'm not really sure what it's asking here. So hero.call data, is that what it wants? Not really sure what it's asking here. Tip my hat to myself. You know, that was just beautiful. That was just beautiful. Okay, so hero.call data. So the hero is another function from another contract, maybe it looks like, and we're passing that data up through that function. Basically, we're hoisting the data through these functions, I suppose. I think is roughly what's going on. Okay, so fallback when data is, well, hold on, actually let's go back real quick. I want to see the test real quick for this stuff. So bool address hero. Oh, it is. Okay, so we do have a setup. We set hero to new hero. Hero is public. Let's see, import hero from Sol. Okay, sweet. So this is another contract, the hero contract. They pull it in and instantiate it here, and they actually set it with the setup. The setup must be triggered with the constructor, I imagine. Or maybe that's where the setup gets fired when this test is deployed. And that is what they're passing in. So they're passing in that hero to here. This contract is getting passed into here, and then we're passing that data upwards to that contract. Interesting. I believe. Let's double check. So hero's hero. But then how do you receive the data? Where's the hero coming from here? We just pass it to the data, or we're just calling this contract or something? A little bit vague for me still. A little bit vague. Gonna be honest. A little bit vague on what's going on here. So we have the hero.ambush. Trying to understand. So I understand this, that they're triggering or passing in the hero. Oh, maybe they're not even passing in the hero here. The sidekick.relay. Oh, they are. They definitely are. Okay. So the address of the hero contract is being passed in here. Got it. Okay, so that is what's going on. This is the address for the hero contract, and they're calling this data. So does that data then become available for this contract down the road if we want to do things like call the relay? How would you do that? Would it be like a MSG dot? I can't edit it, but these are the things that are trying to make me understand. So would that be MSG dot something like data, and then we have the call data for this? I'm unsure, but we'll figure it out. We will figure it out, guys. Okay, so fallback. Let's do it. So when data is sent to a contract and it doesn't match any of the contract's function identifiers, the first 4 bytes of the hash of the function signature. Oh, okay, so that's the first contract identifiers. The contract's fallback function will be triggered. Awesome. That's great. So this means that if you send a random 4-byte value to a contract, it will most likely not match any function. It will invoke the fallback function if one exists. The same holds true if you send less or more than 4 bytes. As long as those initial 4 bytes don't match a function identifier, the fallback function gets triggered. Okay, so the same holds true if you send less or more than 4 bytes. Interesting. As long as those initial 4 bytes don't match the callback or the function's identifier, then the fallback gets triggered. It's not registering, guys. And I got to be honest, I'm reading it. It's not registering. It's not registered. I'm reading it. The words mean nothing to me. They mean nothing. So when data is sent to a contract, if it doesn't match any of the contract's functions, so if it doesn't match the function's signatures, which I guess is what the call data is, so the cache is hashing all the functions, and that's how the functions are identified, is we have the 4 bytes from that function that's hashed on the blockchain. Is that what's going on? That the functions in the contract are getting hashed, and the functions themselves have bytes with it. So that's like the function signature. Is like on the last one, the sidekick, or this one right here, make contract, that's a function. Or if we built a function hello, right? So what I understand is this is all getting hashed into, like when we encode it, this is getting hashed into something. And basically what it's saying is if someone calls for a function and these first 4 bytes, when someone calls for this hash, aren't identified, let's say the call looks like this, just a little bit different or something, and there's no function here that matches that. Let's say this one is OX, this one gets hashed to 7F88 something. So basically the first bytes are different. What I'm understanding is now we have to have a fallback function. So trigger the fallback. Is that what they're saying? So trigger the fallback function here. In the make contact method, send some data to the hero contract that will trigger its fallback function. So hero.call, we'll just pass it some random bytes. We'll give it this. No. Okay. See how that goes, right? That's pretty cool. That is pretty cool. Guys, I feel like I'm understanding it a bit more. That's kind of cool. All right. Oh, it makes me smile internally. Not gonna lie. Okay, guys, so I think that wraps up today's. I do want to give you a little sneak peek of what I've been messing up with, the Remix Ethereum IDE. So this will be just a little bit of bonus content for y'all. Here we can go ahead and code just like and deploy contracts, right? Like online, let's just build one really quick. So this will be hello.sol, and I could say contract. Let me zoom way in. First of all, I need my Pragma and Solidity identifiers, but we can say contract hello, and then I can go ahead and build a few things. So I can map like my addresses to some strings, and I'll say this is my messages, and check this out. We could have a function. We'll say create message. This is going to be fun, guys. And we'll build a proper front end for this, but right now I'm just going to deploy it to the Sepolia testnet. Is it Sepolia? Sepolia? Am I saying that right? But okay, so we could have a string in memory here, and I'll say it's the message like this, and I'll make it a public variable. In function, it will be, oh boy, I'm under pressure now. So the message is from the msg.sender will be the underscore message. I think that'll create a message, and then we can function get message, which will be a address here, and I'll be the owner for this address. So we'll need that. And then I'll say public view returns string in memory, and then we'll return a message from the owner's address. Boom, guys, so sweet. We just built 2 little functions here. I don't think we need to do constructors or anything. Let's compile this contract and let's deploy it real quick. So compiling, and I've already got this. Oh no, I don't have it pre-configured. So now my MetaMask is set up here. I'll deploy this contract. Boom, my MetaMask pops up. Pretty cool. You can see we have a price of it, and this is all faucet ETH, so it's not real Sepolia's ETH. So I'll send it, and we can see here it should be deploying. We should have something letting us know it's deploying. Should be a terminal or something. Oh, boom, there it goes. So boom, right here. Here's the contract that just got built, and we should be able to configure it. So I'll move my face to way over here, and we can create a message. I'll say, hello, guys. and I'll create the message. We should see the MetaMask pop up with a price to send off our stuff. This is cool. This is cool to me. This is like literally freaking 4 years ago when I got into engineering, built my first node on pre-search, with like a cloud server using Volter, and like SSHing into the server remote, and then downloading Docker and downloading pre-search's SDK on the node. I was like so just ecstatic, like, oh, and here's my wallet address, and it was working, and I was getting paid like 2 cents a day from it, and I just loved it. But I'll be honest, I had no idea what I was doing. It took me like 15 hours to do that, and today it would take like 5 minutes, but like then I didn't have it. It was still, I don't want to say like I know what I'm doing now, but like I still don't know what I'm doing, but I know more of what I'm doing. And to be able to at this point be like, oh, this is what I want to build. And now I can send a message right on the blockchain and understand what's going on from my wallet address to this contract address. We can look at this contract and you can see this transaction that just happened for this fee for this service. And this is going to actually be the hash for that message, right? But if I want to get the message, I could pull down my wallet address, either from the contract that happened, right? So from this wallet address, and I can actually get that message. Oh, hello guys. Right there in the bottom left. That's pretty cool. And that's straight from the Sepolia blockchain, the Ethereum testnet. So that's pretty freaking sweet. So I'll have a build for y'all on stuff like that, and walking through on setting up a little bit of the Sepolia stuff. But that was it right there. That was like all of it right there. So, but I'll have some more challenges and builds along the way. I think it's gonna get really fun. So I'm excited. I hope you guys are too.